All right, guys, here we are, topic 18, student activity sheet 2. We are going to explore solving quadratics by graphing. Okay, so you remember Vincent and Bobby from the previous activity sheet. What they were wanting to know, they were wanting to know how long it would take for a balloon to hit the ground after it was launched. Okay, so with that, they gave us the equation right here. The function that models this situation here is 0 equals negative 16t squared plus 64t, where that t stands for time. Okay. And the 0, what that 0 is when the height is 0, meaning when is the balloon on the ground when it equals 0. So we're going to go ahead and graph the following function, and you can use either the points that we put on the previous page, or you could also head to Desmos. And let me turn this off so you can see. I've got the function here. You can kind of see what it looks like, but this is just zoomed in a little bit on my graph so you can see it better. Okay, and let's just take note of a couple things. So I have the graph here in purple. The balloon is on the ground at 2 points, and I circled those 2 points at 0, 0 and at 4, 0. 0, 0 stands for landing. That 4, 0 is when, the 0, 0 is when it's first launched. And this one over here is when it hits the ground. Okay, we also call these x-intercepts. Those x-intercepts are at 0 and 4. Okay, so now here we have another situation. And this is they are going to drop a balloon off of the top of a house, off of a school building. Let's see if we can get this to switch here. And what they're doing is they are starting 10 meters up off the ground, and they want to know how long it's going to take for it to hit the ground. So we've got Bobby and Joseph. Here they are, and we're going to go ahead and drop this balloon, and we can see roughly what it's going to look like there. Okay. And when we go ahead and we graph this, again, you can see what that looks like. So using this piece of information, let's go ahead and turn the page. Okay. They want to know what function might represent the balloon's height, h, as a function of time, t. So this is exactly what we were doing before. Okay. It is a transformation of our function y equals x squared. Now, we haven't learned a whole lot about that, but what you need to know is that this takes the shape of this is a quadratic. This is what we've been factoring, but this is a parabola. Okay. And let's go ahead and look down here at number 6. So they said to graph this equation on our graphing calculator. I'm going to go ahead and switch this over here so you can see. All right, and we're going to zoom in here. So all I did was I went ahead and graphed this, and I'm only graphing the one side of it because we don't care about the other side. So I can see roughly where it's going to hit the ground. I'm going to call that between 1 and 1.5 seconds because 1.5 is about right here. Oh, no, a little bit more. You can zoom in and see that. Okay. So they want me to write an equation that can be solved to find when the balloon will hit the ground surface. Again, they give you this equation. That equation is going to be 0 equals 10 minus 4.9 t squared. That's our equation here. When it hits the ground, okay, or when it hits the surface, that is at 0. Again, 0 is always going to be our ground / start or end. Okay. And with that, they want to know what is the root of an equation. Okay. The root of an equation is a solution to an equation when y equals 0. Okay. This is also called our x-intercepts that we just found up here. And in this particular problem, what is the root? I'm going to go back here and I'm going to see where does it equal 0? And they give me at 1.429 is the root. What does that mean? That means at 1.429 seconds, the balloon hits the ground. Then they want to know what is a 0 of a function. Well, guys, 0 means the same exact thing as a root, which means the exact thing as solution, which means the same exact thing as the x-intercept. A 0 is what makes the function have a value of 0, meaning y equals 0. Again, also called a root, solution, intercepts. Okay, so you can see over here, this is considered a 0. It is considered a root. It is considered an x-intercept, all of which are the same. Okay, so let's take a look at question 11 now. What does this point mean for this specific situation? Okay, this point means that it represents the time in seconds, 1.429 seconds, when the balloon was 0 meters above the ground, meaning when it hits the ground. So what do we notice about the second intercept? I'm going to go back so that you guys can see that. Oh, you can see it on here too. This second intercept is over here, okay? What do we notice about it? It's negative, indicating that time is negative. Time cannot be negative. Information for this scenario can only have x values greater or equal to 0, meaning time can start at 0 or it can go on from there, but we cannot go back in time. Okay, question 13 you'll do with your teacher. Question 14 and 15 you will also do with your teacher, as well as 16 and 17. And then I will see you back here tomorrow for student activity sheet 3. Bye.